Hey everyone, and welcome. Today we're going to talk about a piece of tech that's quietly working behind the scenes, making all the incredible AI stuff we see today even possible. We're talking about a secret superhighway for data. Okay, let's just jump right in with a statement that might sound kind of crazy. You hear all this talk about more and more powerful GPUs, right? But what if I told you the biggest thing holding back AI and high-performance computing isn't the processors, it's the network? We're creating a literal tsunami of data, and the old pipes just can't handle it. So that brings us right to our first topic, the AI data bottleneck. Let's really dig into what this problem looks like. I want you to picture this. In a normal network, your main computer processor, the CPU, has to act like a traffic cop at the world's busiest intersection. Every single little packet of data has to stop, get inspected, and be told where to go by the CPU. This creates a massive traffic jam. And even worse, it's stealing all that brain power from the CPU that should be doing the actual work. The number crunching we need for AI. Now, this is such a huge problem that some really smart engineers came up with a brilliant fix. Which brings us to our next section, where we get to meet the hero of the story, a technology built for one purpose: bypassing the CPU. And that hero's name is RDMA, which stands for Remote Direct Memory Access. The name really says it all. It's a way to create a private express lane for data, letting the memory in one computer talk directly to the memory in another. It completely cuts the CPU out of the conversation. This is the magic that makes huge AI training clusters even possible. This slide really shows you the night and day difference. I mean, look at the left. The old way is this slow, clunky process where the CPU is just constantly getting interrupted. It's a mess. But then you look at the right, with RDMA. The app talks straight to the network card, the data zips over and gets placed right where it needs to go. No CPU, no extra copies. The result? Super low latency, and the CPU is free to do its real job. So, RDMA is a total game changer, right? But historically, it meant you had to buy all these expensive, specialized networking gear. So the real question became, how do we get all this power to run on the network that basically runs the world? Ethernet. Well, that's where the next piece of our puzzle comes in. RoCE, the Ethernet Superhighway. RoCE, that's R-O-C-E, stands for RDMA over Converged Ethernet. And it's the key. It's basically a protocol that wraps up all those powerful RDMA commands and lets them travel over your standard everyday Ethernet network. Specifically, the modern version, RoCE v2, is what's used in today's massive data centers. So the really big deal here is that RoCE v2 isn't some weird special snowflake. It works with the same tools that run the entire internet. It can be routed across huge networks, it can prioritize the important AI traffic, and it has really smart ways to manage and prevent those data traffic jams we were talking about. Okay, but there's a catch, and it's a big one. For RDMA to really work its magic, you absolutely cannot lose a single packet of data. But standard Ethernet? It was literally designed to just drop packets when things get too busy. So how do you fix that? Well, that leads us to our next big challenge, building a lossless network. Our first tool for this job is called Priority Flow Control, or PFC. Think of it like a really smart traffic light system. If a network switch sees that the lane for our super important AI data is about to get clogged, it sends a pause signal back to the sender for just that lane. It says, hey, hold up for just a microsecond, which prevents any of that critical data from getting dropped. In practice, the idea is pretty straightforward. You basically tell the network, okay, this AI and storage traffic right here, this is VIP. It's no drop traffic. And once you do that, the hardware just takes over. It automatically and intelligently pauses other, less critical data to make sure the important stuff always has a clear path. The other key tool is called Explicit Congestion Notification, or ECN. Now, if PFC is the stoplight, then ECN is like one of those digital signs on the highway that says traffic slowing ahead. As a switch starts to get a little busy, it doesn't just wait for a total jam. It starts putting a little flag on the data packets, telling the servers, hey, things are getting a little crowded up here. Maybe you should ease off the gas a bit. It's a proactive early warning system. So let's put it all together. On a regular old network, when it gets congested, packets just get dropped. Then the application has to realize what happened and waste precious time resending the data. It's super inefficient. But on a lossless, RoCE network, traffic is managed intelligently. PFC hits the brakes when needed, and ECN gives an early warning. The result is no packet loss and a smooth, incredibly efficient superhighway for your data. Okay,
So we've done it. We've built our perfect superhighway. It bypasses the slow traffic cop, and it's so well managed that data never gets lost. So what does that mean in the real world? How fast can this thing actually go? Let's take a look. Wow, just look at that number. In a benchmark test on a 100 gigabit Ethernet RoCE network, the total bandwidth hit an incredible 389 gigabits per second. To give you some context, that is an insane amount of data, like downloading dozens of full-length HD movies every single second. But what happens when you turn up the dial on the hardware? Well, with a 200 gigabit Ethernet network, that number just explodes to a mind-blowing 766 gigabits per second. The performance scales almost perfectly. It's just staggering. This chart just makes it so clear, doesn't it? At 100 gigs, we're already seeing that massive 389 Gbps number. But you double the network hardware to 200 gigs, and the performance more than doubles right along with it to 766. This isn't a tiny improvement. This is a revolutionary leap in performance, and it's exactly the kind of speed you need to train these giant AI models. And that really gets to the heart of it. One of the sources we looked at put it perfectly. RoCE is a fundamental component in ensuring a reliable end-to-end transport solution for modern data centers. This isn't just some niche thing anymore. It is absolutely foundational to how we build our modern digital world.
So what does all this crazy speed actually mean? It's not just about bragging rights with big benchmark numbers. It's about what those numbers actually enable us to do. Which brings us to our last section, the future is faster. This kind of network speed unlocks a whole new world of possibilities. For AI, it means GPUs can talk directly to each other, which speeds up training by a huge amount. For storage, it means things like SMB Direct and NVMe over Fabrics can make a storage server on the network feel just as fast as a drive plugged right into your computer. We are basically erasing the distance between where data lives and where it gets processed. And that's the big takeaway here. By creating this lossless CPU bypassing superhighway, we are finally solving the network bottleneck. And when we do that, we unlock the true incredible potential of all the amazing processors we've built. Which leaves us with one last really exciting thought. For decades, we've had to design all our software around the limitations of a slow network. But now that the network is no longer the bottleneck, what new possibilities open up? What will we be able to build next?